Hello everyone. So we will continue with our topic, that is the finite automata with output. This is the second part. It consists of the Mealy's machine. In the first part we have done the Morse machine. The Mealy's machine, each output is associated with each input. So that means for every input there is an output. It is represented again exactly similar to the Morse machine, that is Q, the capital Q, the sigma, the delta, the small delta, the lambda, and q0, which is again represented by the same thing again. The finite set of states is q, which can be q0, q1, q2, and so forth till qn. The input alphabets can be 0 or 1 or any other. There can be many. The output alphabets, again, it is associated with the input, so let's consider it as 0 and 1. These are examples. All of them are just examples which I'm taking. The transition function, again, is in combination with the input with the states. So if you see this transition diagram, the states are this side and the inputs are on the top side. Similarly, the output, which is represented by lambda, I'll be giving you how it is represented, and the initial state is given by q0, which is this one, and we can always mark an arrow there to say that that is the initial state. Now let me explain about the transition table. This is the transition table. So if you notice here is for q0, the state q0, for an input of 0, the output is 0, which goes to state q2. Same thing from q0, if the input is 1, it goes to q1 with an output of 0. So it repeats the same way in this process. q1, if the input is 0, it goes to q0 with an output of 1. So it goes on repeating this way. So this is your entire table and how it is being represented. Similarly, as a Morse machine, the Mealy's machine can also be represented as a transition diagram, which can be given by, let's draw the diagram here. This will be a transition diagram. Let's make it as q0, q1, q2, and q3. So here what we have is q0, it goes to q2, sorry. q0, it goes to q2. If your input is 0, your output is 0. So we can always represent like this, 0 oblique 0. Similarly, q0 to q1 with an input of 1, it gives an output of 0. So we have q0 to q1. If your input is 1, your output is 0. So repeat the same process, q1 to q0. So q1 to q0. So 0 with 1. That means your input is 0, your output is 1. Similarly, q1 to q3. q1 to q3. If your input is 1, your output is 0. So 1 oblique 0. Again, repeat the same thing, q2 to q1, q2 to q1. So let's make an arrow from here to here. Input is 0 and output is 1. And q2 to q0. So q2 to q0, q2 to q0, 1, 1. So let's make it 1, 1. And q3 to q3, so let's just draw like this. So it is 0 oblique 1. And q3 to q2, so q3 to q2, which is represented as 1 oblique 0. So that is how the transition diagram is represented. Similarly, the output function lambda can be represented by lambda q0 Q2 over 0 will give you 0. Lambda Q0 to Q2 over input 0 will give you 0. Repeat this process. Lambda Q0 over Q1 of input 1 will give you 0. So in this way, we can always repeat the remaining output functions. Thank you for watching this video.